Howdy, howdy, guys. Welcome back to Cruise Man's Inventions. This is what the trike used to look like with the motor on it. I'm just going to go through some things with you. It's mainly to do with the charging problems I had when I converted it with the washing machine motors. I took this motor off, which was a Honda GX120. It's a 4 horsepower. It's a 198cc. And absolutely beautiful motor, I must say. Oh, that's my cat. No, next one. Okay, so as you saw through my last videos that I took the motor off, I'm kind of fast forwarding through this, guys, and I put the washing machine motors on here. Now, the part where I'm up to now, if you've been following the washing machine drift trike story in my other videos, guys, is this is the charging side. I have two of these on this drift trike. This is on the right side, and I have one on the left side. Okay, so the charging part is this. So I was getting, as you know, I split this into three different parts, right? And which made the voltage come down and the amperage come up. And because the controller I'm using on my bike is 800 watts at 48 volts, but I've upped it to 72, as you can see on the handlebars here. It's left in middle gear. This whole system is not very economical, and I'm only using this generator as a regen unit, and I don't think it's as economical as a alternator, but we're going to do the test anyway soon. So okay, this is what it yielded, was 100, I don't know if you can see that, but 135.4 volts off that. And I chopped that part out. I chopped quarter of that motor out, right? That's what I was showing you back here. Was right in the beginning was I chopped that wire. So I chopped a quarter of the phase out, only leaving two of the phases. But what I forgot to mention is every one of these phases produce 130. And that quarter 130, and that quarter 130, and then they're all joined together, producing 3 times 130. You see what I mean? So we're going to fast forward again. So we had 72 volts on the clock. I wound the throttle back, and this is my response still off that generator. That's my face. I was like, huh? So I had to work it out, right? So I got back into it. That's what it looks like at the back. And so I came up with another theory. I thought, what if I got a capacitor? Well, actually, this is the part where I explain I could either do two things or something or other. I could change the gearing, I could make that smaller so it didn't spin so fast, so therefore, but if I was going downhill, then it would still reach over 100. And I've changed the capacitors out of my controller from 80 volt capacitors to 100 volt capacitors. So now I can pump more volts through it, you see. But I wanted it only to go to under 100. So what I came up with was another method. So as you saw in my graph here, I don't know how well you can see that, but in my other video I had this up, and it just explained how much power you can get out of the poles, right? Just with three on the AC side, because you're only measuring it from two, just stock standard wire is 25 volts AC. Now, if you put that through half-wave bridge rectifier, coming out of 2 pins, that's 22.5 volts. And if you come out of 3 pins through a 3-way bridge rectifier, you got up to 30 volts. Oh my god, I got something on my camera here. Hang on, guys. I don't know where it is. There it is. Oh no, it's not. Okay, it's still on there. I don't know what that is. So anyways, guys, so yet again, had to come up with some sort of an equation to bump off that 30 volts off the initial 100. So I come up with my iron lithium battery charger. I thought I'd pull the capacitor out of it, and that's what that looks like on the inside. Thought, well, if I just put that capacitor on it, maybe it'll bump down the power a little bit. That's that's a one-way blocking diode. It's quite a big one. And that's that capacitor. Now, it was 120 UF at 400 volts. Now, I thought I wouldn't be able to max this thing out or even blow it up. So, as you can see on the one side here, we have marks and directions, and that actually stands for the negative side of it, even though these are AC capacitors. Strange. Anyways, so I proceeded to link it into the two phases and link those other wires back in. Then I shoved it back. There it is. See? Then I shoved it back in the bike, and then the thing blew up on me. I spun back the throttle. It went up to what was it, 40 or 50 volts. It was rising, then dropping, rising, then dropping. Then this thing smoked its ass off and just about blew up inside. So I had to cut it and chuck it on the grass. And so therefore, I then proceeded to go back over my wiring, and you see the 3 poles at the end here where it's tapped off normally on a normal washing machine. That's how they tapped off at the end. Well, I got rid of the 3 last poles of every 12, right? Because it's 3 lots of 12 in here. So I got rid of every 3 off the end. Okay, and joined them back together, right? And then I spun that up. Oh, I gotta show you this. Because this is aluminium, and you scrape back all the laminates and tie it together, you need copper. You need to wrap it around with copper to be able to solder it. And that's a very vital part right there, and I don't want to miss that out, because otherwise the solder will just run off that, and you won't get anywhere. It won't be a very strong. So after wrapping the copper around it, that's a good little button right there. Beautiful. She checks out, and there we go. That's what that yielded now, from down to 130 down to 101. And so that was still too high for me. So then I proceeded to pull it out again. Well, there we go. That's a second reading. It's under 100 now, but it still wasn't. Oh, so that was the last reading. That's right. After me pulling it out, and I went back over that motor again, and I pulled out a whole bunch of copper. I pulled out like 30 windings out of every 3 of the last windings, and then it conquered it down to that voltage there. So now it's under 100 volts at full revs. So, and so yeah, guys, I pulled more than that out. So I'm going to turn the light on now, guys, and face you around to the actual bike. Oh, right, because that was a bit of a slideshow, and I'll try and get some more light in here. And I am actually going to do the distance test, guys. It has to be darked out here so I can show you guys a lot of stuff, right? So, yeah, at the end of... So, yeah, those ones are still open. They're still cut open. Those are the ends. So, as a matter of fact, I could have joined these 3 up, the other 3 that's open, and the other 3, and had another 9 poles linked into the system. So, really, you only need 9 poles to get up to, 90 odd volts or whatever. But I took off for the last 9 poles. This is the open ones. Here's the tied off ones. I took another 30 wraps off each one of these end poles just to bring the numbers down. And it worked a treat for a generator. You can do that with them. I will do the distance test on it, but I have some more work to do, guys, under here. I don't know if you can see this, but I'll try and get under here. See the sprocket here? This is the one on the generator side. I don't know if you can see that, but the nut, when I tack welded the nut on, there's one here, there's one on the other side here, but I gotta take all of this off and re-weld it before I can do the distance test, guys. That's what's holding me back. That, and it's raining. So yeah. So, but I will definitely get to you. For now, I'll be up on this chair having a sleep. No, so so yeah, there's the controller. You can use a 1000-watt controller. I wouldn't go any higher than that. And like I said, would I swap this out for an alternator? Yes, I would. Did it need more copper in there to be stronger? Yes, it did. Does it need neodymium magnets in it, apart from these ceramic ones, to make it stronger? And maybe hall sensors? Yes, it does. And where would you put the hall sensors in something like this, since it's wound like a washing machine, with the ABC phases being right direct to one another like that? Well, I'd say that you'd put them smack bang on the three phases. That would just bring it around slightly every time to take off, right? So, but on an e-bike, it's wired differently. Um, and if you wired one of these like an e-bike motor, would it work without hall sensors? And I do believe it will. Um, but you'd have to get a controller that has two mode. Oh, sorry about that. That's my timing, guys. With two mode that can run with hall sensors and run without hall sensors. Then, when you rewind this as an e-bike motor and with that certain controller, it will work. Yeah, it's sensor and sensorless controllers is what they're called. So, yeah, so that will work too. So cool, guys. There we go. Still some more work to go on it. It's getting there, and the distance run is definitely coming up, guys. I don't think I'll get very far. I can't get very far without this thing overheating, and I don't get the same problems with the alternator motor at all. But yesterday I just put a bearing in the inside of this, and I'm going to fix up Nemo again. It was running a bushing in the back, and it was heating up to the max. I'm going through all the center wire inside here, and just making sure it's not cooked. And that's 110 truck one, so that should be interesting. I might put that on here if it works out. So yeah, awesome stuff, guys. Woo! Well, I hope that's certainly helped somebody out, guys. Oh man, I built all sorts of stuff through time, a lot of stuff. But that's why I thought, it'd be interesting just to put some of this out there. Maybe it could help some of you. So there goes that rain again. Cool, guys. I'll try and get this posted now. Cool. Cruiser man out, guys.